Okay, a very good noon, my dear student friends. So, as I had told in my previous class, we will take up one more problem on control chart for variables and try to discuss about the patterns. That means control charts of variables, the pattern for control charts for variables. That is what we will try to analyze this one. What are the different types of these variations will be there and how to recognize them. Okay, before that one, I just would like to take one more example so that it will make the things more clearer for you. Okay, I'll just read, you just take down it. A certain product has been statistically controlled at a process average of 36 and standard deviation of 1. These are some units. Okay, that means process average, that means x double bar, it is given as 36.0 and the standard deviation of 1. So, x bar prime and sigma prime are given. That process, this is what? The certain product has been statistically controlled at a process average of 36.0 and a standard deviation of 1. That means sigma prime is given and x bar prime is given. That x bar prime has 36 units and sigma prime is equal to 1. The product is presently being sold to two users who have different specification requirements. User A has established a specification of 38 plus or minus 4.0. That means user A's specification of user A. That is what I am mentioning over here. And user B has specification of user B is 36 plus or minus 4.0. Okay? Specification of user A 38 plus or minus 4.0. Specification of user B is 36 plus or minus 4.0. Now, based on the present process setup, what percent of product produced will not meet the specification set up by user A? Okay. First one is A part. What is to be found out is the percentage of the product which will not meet the specification of the user A, or rejections of user A, and similarly the rejections of user B presently. That means presently means with process average of 36.0 and standard deviation of 1. Okay. C, assuming that the two users' needs are equal. Now what has happened? Their needs are different, 38 plus or minus 4 and B is 36 plus or minus 4. Now, assuming that what he says is the two users' needs are equal, a suggestion is made to shift the process average to 37. New process average is shifted to new process average or I can say x bar prime new is equal to 37. It is shifted to 37. At this suggested value, what percent of the product will not meet the specification of user A? That means under this one, when it is shifted to 37, then the rejections of user A and similarly rejections of user B. Okay, that means three parts, and the fourth one, do you think that this shift to a process target of 37 would be desirable? Explain your answer. Fourth one, whether setting of new process average is desirable or not. Okay, it consists of four parts. Mainly I am going to explain you about how to make use of this normal distribution table. And in fact, it throws some light on how the processes averages can be shifted so that the rejection rate can be reduced. Just by shifting the process average, how the rejection percentage can be reduced. In yesterday's problem also we have seen that one. So at the end of this session we are going to conclude what are going to be the benefits or what is the objective or what are the uses of these control charts for variable. That is the whole idea. Okay, if the time permits, we will study few of the patterns of these control charts for variables. Okay, that is the today's task. Okay, now let us see how to find out under the present circumstances. That the present circumstances is what? X bar prime is 36, standard deviation is 1, rejections of user A. And the product, whatever is produced with process average at 36 and standard deviation of 1 will be rejected for the user A. That means if it doesn't meet his process requirements, okay, specification requirements. So what is the maximum value he wants? Maximum value he wants is 38 plus 4, that is maximum value he wants is 42, and the minimum value he wants is 34. So the product, the dimension variation can be between 34 to 42. And before this one, we should have thought about whether the process is capable of meeting his requirements. So that is what we need to find out. What is the process capability? Process capability is what? 6 sigma prime. Now the sigma prime is 1. 6 sigma prime means what? It is 6 into 1, it is going to be 6. This 6 is lesser than the difference between the maximum and minimum values. What this one? That means we were talking about maximum value minus minimum value If it is greater than the 6 sigma prime, and all the products, whatever they are being produced, okay, they can be defect free. But you might start wondering, why this question is asked. What is the rejections of user E? Because that you need to think. The process is capable of meeting. It says this process capability, that means process is capable of meeting the requirements, but something is wrong. Wrong adjustments have been made, which can be corrected. That is the objective of, one of the main objectives of the control chart for variable, especially X bar chart. Try to understand this one. So we'll see how the rejections are there. Okay. Why the rejections are there and what for. That is what we need to understand. Okay. Now if you look at this one, why the rejections are there, then that is what we need to think. Okay. Why the rejections and how it can be reduced. That is what we need to think about this one. Okay. Now process is centered at 36. Okay. Now process is centered at 36. The minimum value required is 34. What is going to happen? Okay. What is going to happen? What is happening now? Now the process is, this is the process average. If I look at it, 36, it is behaving like this. Okay. This one is 3 sigma level from this. So this is 33. This is going to be 39. And if I plot with the different colored, this one, specifications limit, the specifications limits are here. One is, this is 34. 38 minus 4, this is 34. And this one is 42. So virtually what is happening? Virtually nothing is being rejected for not meeting the upper specification limit. All the parts, they will satisfy the upper specification limit. But few parts, they will not satisfy the lower specification limit, because he wants it should not be lesser than 34 mm, but these many parts are being produced with less than 34 mm minimum requirement dimension. Is it understood? That means this area I need to find out. The remedy is also known. What is the remedy? Instead of making this average, now it is 36. Most of the things are being rejected for not meeting the lower specification limit. Then you shift this average. Average will be bodily shifted to in between values. In fact, maybe 38 might be better for this particular fellow. But if it is shifted to 38, what is going to happen? Because this example, if you analyze, because that is the power of analysis. If you analyze, now you could have said, instead of 36, he wants 38. No, why you don't want to make it in the middle of this 38? Instead of 36, you maintain at 38. Okay, yes, his rejections will be reduced, but what is going to happen to the specification user of B? His 36 plus or minus 4. His distance will increase, rejections will be increased. That is what precisely we are trying to do. That is why they might have taken the decision to bring it to 37. Neither 38 nor 36. In between that value is 37. And try to observe one more thing. We never talked about the standard deviation because it is very difficult to change the standard deviation. That is why we say that the variation is inevitable. This variation is inevitable, sigma prime. Try to understand. But not changing this variation is, this will remain like this shape only for this particular process. But its average can be changed. That is what I was talking about. Accuracy and precision. Precision of the system remains same, namely sigma prime is equal to 1. Now the accuracy I can change. That is the process average value I can change. I can, instead of 36, I can make it 37, or I can make it 38, 39, like that, by some simple adjustments. Is it understood? Now I need to find out what is this area, because nothing is being rejected because of not meeting the upper process limit. Upper specification limit. So I will find out the Z1 value for this. Okay, already I told you that the normal table, whatever we are going to refer, it starts with minus infinity. Try to understand, from minus infinity to plus infinity, whatever the table we are going to use. But some of the statistical tables, they will have given only half. That means it will be 0 to plus infinity, or this one 0 to minus infinity. Either way it will start. But this one is much more better. Whatever the table we are going to refer is much more better. If I want to find out the area, it should have two ordinates. In this particular statistical table, which you have been provided, one of the coordinate is minus infinity. Another coordinate I need to find out. That I explained in the previous this one, that standard normal variate. I need to find out that Z value. Now I want to find out for this much area. That means I will be converting these given things with different average value and different standard deviations to standard normal variate Z. Hence I can make use of the standard normal table. That is the whole idea. Okay. Now that is given by, that Z is given by, Z is equal to desired value, let me say X, minus, this is average value X bar prime, sigma prime. Now desired value is what? This one I want. Okay. Now what is happening? Below 34. What is this percentage? Below 34. Because this one 38 minus 4 is 34 for that purpose. So I am taking 34 minus 36. Standard deviation, I don't do anything about it. So this will become 1. Hence, this will become minus 2. Z is equal to minus 2. If I refer the table, Z is equal to minus 2, you can get the value. Okay, I can just show you the table. These are the tables. Okay, here Z value, and these are the fractional values. So these values are, it varies from minus 3.5 to plus 3.5. All these things have been calculated, and how it is to be used, this is given over here. Okay. Now if I refer that area, that means from minus infinity, now I have found out minus 2. That means this, if it is plotted on this one, minus infinity to this one, this is Z is equal to minus 2. So how much? If I refer the table, it says that it is 0.0228. Okay, 0.0228. Area is 0.0228. Okay. Presently, so much these things are being, that means, that is what it says, that so many defective parts are being produced. That means, what percentage? This is equal to 2.28%. The answer for this one is 2.28% for not meeting the lower specification limit. And what number of parts will not be meeting the upper specification limits? That we can find out. How we can find out that one? 38 plus 4, 42 minus 36. That means 6 divided by 1. Okay. So that area we will find out. That means plus 6. That means minus infinity to plus 6. It will manufacture the good items. Beyond that 6, it will be manufacturing the defective items. So if I refer the table says that up to 3 plus 3.5 itself is almost 100%, 99.8%, 99.73 or 99.8% itself it is covered. That means virtually no rejections will be there because of not meeting the upper specification limit. That will make it as 0, consider it as 0 rejections. So the total rejections of the user A is 2.28%. Okay, this is the one. Now rejections of user B. How do you calculate this one? The same way. What we will do is, now 36 we have put it for user B. How it is to be calculated? The same way we are going to calculate it. This time I will try to represent in vertical way. Okay. This is 40, 32. This one is 40. Okay. This one is 40. And the process is something like this. It is behaving like this, whereas its central value is 36 because it is at 36 mm. That is the reason, precise reason. Okay, now I need to find out this area and I need to find out this area. Well, these will not meet the lower specification and this will not meet the upper specification limit. So, if we calculate these things, what is the thing we are going to get? All the parts are, because it is exactly in the center of this, so all and process capability is less than the difference between maximum minimum this one is 8 and whereas 6 sigma prime is 6, hence all the parts will be meeting, or even if you substitute you are going to find out these things are 0%. Rejection is right now with the 36 as the process average for user B, the 0%. Okay. For user A, it is 2.28% rejections are being produced. This is the answer for the B part. Now, C part we have to do. Same thing. We'll change it to 37. Instead of using 36 as the S bar prime, I will make it as 37, whereas the specifications limit, they have to remain the specification, upper specification value and the lower specification values, they got to remain same. So for A, if I want to calculate that one, now instead of this one, what has happened now is, this has become 37 and I will put the upper specification limit for A. Upper specification limit for this one is 42, 38 plus 4, 42, and the lower specification limit is 34, 38 minus 4, 34. This is what has happened. Okay. Now again I will find out what is the difference between these things. Okay, by shifting what is going to happen. Now again upper specification limit, what is the percentage I can find out by finding out these things, that is again Z is equal to X minus X bar prime, this is the new sigma prime, that's the same thing will remain same, So x is 42 minus 37 divided by 1. So this works out to be 5 plus 5. Again, that means almost all components are within the specification limit. So no rejections will take place for not meeting the upper specification limit. We'll find out for the lower specification limit. Lower specification limit, we are substituting it to 34. So 34 minus 37 divided by 1. So this works out to be, that means it is minus 3. Minus 3 corresponding area, if we look at it from the table, it is area is 0.0135. That means about 0.135% of rejections will be there by changing this one. The 0.135% of rejections will be there. So total rejection for A is what? Earlier we found out for this one 0%. For this one it is 0.135%. So the total rejections would be 0.135%. Whereas earlier it was 2.28%. Under the new circumstances, it has been reduced to 0.135%. Okay, instead of 2.28. Now similarly, we will calculate it for B. Again, we will substitute. What are the values we are going to substitute? Because I am not going to again rewrite the same thing. Here the thing is very simple. Here this one is, this will remain 37. This is 40. That means 40 minus 37. This is plus 37. Plus 3. Okay. That means here the rejections will be not meeting the upper specifications limit. In the case of B, it is 0.135% of the products will be rejected. Earlier, 0% was being rejected totally for B. Okay, but now it is increased to 0.135%. Okay, and plus not meeting the lower specification limit. The lower specification limit for B is, that is the 32. Okay, that will become 32 minus 37 divided by 1 minus 5. That means virtually nothing is being rejected. So because of changing this scenario, the total rejections would be 0.135% for the user A and 0.135% for user B. Totally 0.27%. What it? Total rejections will be both together, the total rejections will be 0.27%. But earlier case, when it was maintained at 36, it was 2.28%. Which one you would prefer? Naturally, the second thing. That is what here we say. Whether that means, whether the setting of new process is desirable. If so, why? Explain. Because the percentage of rejection, total percentage of rejections have been reduced from 2.28% to 0.27%. So the second thing is desirable. That is, just see what is the power of this one. That means almost 2% rejections will be reduced just by shifting the average. And these things can be only identified through analyzing or through means of collecting the information, analyzing in a proper way. That is why it has got a lot of applications in the manufacturing. Okay? So these things are to be clearly understood. Okay? Now we'll try to think something on, because have you understood the basic things about this one? If so, we'll try to spend some time, because on numerical part, these are the things. Whatever I wanted to cover, the numericals have been taken up and it has been explained. Okay? And sigma chart can be also constructed in lieu of the R chart. It is very simple. There is no point in taking off any numerical on that. Now we will try to think on the patterns, okay, the patterns of the control charts. What patterns? So that we will be able to identify, okay? Because now, what are the things required for this one? If these things are to be analyzed, whoever is going to analyze, if he is only a mathematician, it will not help. If he is only an engineer and talking about without knowing much about the statistics, will not be of help. Because through statistician, he can only say there is something wrong in the process. It is not being, the process is not capable of meeting, or the rejections are being produced. That is what he will tell. Why it is being produced, what could be the reason, it is not possible to analyze that one because of the very simple thing that he may not be aware about the process itself. So these two qualities are required. That is why engineer knowing the statistics is much valued. Okay, try now. So we need to learn these statistics, only these simple forms, only some probabilities. If you are able to understand, that is more than adequate. Statistics only will play with these values, and how to create that value, that we need to think. Okay? If the engineer, he knows about the process very well, hence he can be able to control it. Okay? What is to be exactly done? Because here you can see that you change it to 36. Why? Is it possible? And other things you will have thought, and then do the things. Okay, one more thing I want to talk more about the process capability, because in previous class I said three things. One is whether the difference between the upper specification and lower specification limit is greater than or equal to this thing, then what are the various possibilities like that? Is it exactly equal, or is it less than that, or whatever it is? That means X max and X min. If it is substantially greater than 6 sigma prime, what are the possible ways I can shift the process average? That is what here in this example we have seen. The standard deviation was 1. That means the process capability was 6. Whereas the difference between upper and lower specification limits were 8. So it was more than that. But in spite of that one, it was producing some defective items. That is why we shifted that process average. So we brought it in between value. If it is more, what are the various options left, or in what way it will behave? That let us see what is going to happen. So these things, I'll say, these are the specification limit. That means X min value, X max value, and this is X min value. Average. Now the process, how it will behave, it is going to behave in a normal way. One way it can behave is exactly it is centered in the middle. Okay. Okay. It is less, so no rejections will take place. Okay. Next thing what I can think about is just this one, it coincides with this 3 sigma of this one. So I can shift it over here. Process average is shifted, but still nothing, no rejections are being produced. Or we can say that at the most 0.135% of the rejections are being produced. Okay. Similarly, I can shift it in other way around. Try to understand this spread is same, because on this diagram it might appear to be different, but actually assume that they are same. Here I am going to make it coincident with this. Here a lot of variations will be there. Here I have shifted process average below this midpoint. Here I have shifted this one above midpoint. That is the crux. I just wanted to draw your attention. I wanted to draw your attention in that particular regard. Okay. Okay. Another way, what I can do? Another way, end point itself, not this. Here it is 0.135%, it is not like that. It is below this. These are the possible situations. Which one is better? That if you look at it, which variations we should consider? What variations we should consider? Which one might be better? We can think about what are the variations? This one, so let us say A, B, C, D, E. Which one is better if the question is asked? According to me, first one you give it to this, next this one, next this one, and last these things. If the difference between X max and X minimum is much greater than 6 sigma prime. And try to understand, when sigma prime itself is much less than the difference between upper and lower specification limit, our controlling, that means 6 sigma X bar, because in this case X max minus X min, this will be much greater than this value, because sigma X bar will be much less than sigma prime. It is lesser by square root of n. So we are almost controlling it at the 50% of that. If I am able to draw the control limits on this one, that their width, if I calculate, here sigma prime, I have got it as 1, is it not? But if it is 5, that means sample size, if I have taken 5, square root of 5, that is to be divided by that. That means almost the spread is not going to be 6 into 1, it is going to be something around 3 spread. So there, if something falls above that one, then itself I am going to stop. In reality, nothing, no defective parts would have been produced. I will start taking the action then. Even if my action is delayed bit, then virtually no defective parts would have been produced. The idea is what? The sigma X bar is less than sigma prime, and sigma prime should be less than the difference between the upper specification limit and the lower specification limit. That is the whole idea. Okay? That process you select. Okay? Then you control this thing. That is why always the specification limits should be more than the process limits, and the process limits are more than the control limits I am going to control. Okay? This is the situation when X max minus X min is greater than 6 sigma prime. And if it is equal to, then the problem comes. If it is equal to, that means this is the process average, and these are the control, these are the specification limits. Just it is meeting. Then it has to be in midway, no way out. It has to be in the midway. If it is slightly shifted this side or this side, we had it. That means we will produce defective parts. So in yesterday's example, that is what we have seen. For this one, because that is the spread of the tolerance or the specification difference between specification limit was 22, whereas for natural process that 6 sigma prime was 21.66. That is what we have seen. They are almost equal to. So there we need to be more cautious. Under these circumstances, and the present, whatever we discussed, okay, some casual this thing, okay, no, nothing is going to happen. Okay? And the third option is, this is the case when x max minus x min is equal to exactly 6 sigma prime. The third condition will be what? X max minus x min will be less than 6 sigma prime. 6 sigma prime is greater. In that case, what is going to happen? That means our process limits are these things. Now the specification limits are lesser than this. It will be here. They are different. That means it is inevitable that the situation what? Whatever we do, whatever process changes or averages we do, it is not possible to meet the requirement. In the sense, rejections are inevitable. Okay? Rejections are inevitable. Then the suggestions can be, what could be the suggestions? No, we live with that one and then sort out the bad items from the good items. If it is possible to change the process, you think about that. Second way out. Third one is what? Can we change the tolerance limit itself? So design person. We can contact and say unnecessarily he might have given. So tight tolerances. That is the buzzword which is being used in the industrial area. No, tolerances are very tight in the sense we cannot move here or there. Can it be relaxed? In some of the cases, it can be relaxed. And this gives an indication to that. So first, try to think about that one, whether the tolerance can be reduced. If they say that design engineer, no, it cannot be. Then think about changing the process itself. Existing setup you change. And the third one is what? If it is, because that involves a lot of monetary, these things, economical, these things it will involve. So the third option will be, we have to live with. That means you start separating good, it is inevitable that we are going to produce the defective items, then you sort it out. So that comparison can be made, and then whether to go for the new process or what, on economical terms, the decisions can be taken. This is how it works. And if you sum up all these things, you can answer the different questions which would be asked. One may be, what are the objectives of control chart for variables? What is the usefulness of control charts? What are the benefits of control charts? All these things can be summed up like this. So you try to infer from this one and you can answer these questions. Okay? Okay, my dear student friends, let me see what is the time. No, another 6 minutes I have. So I'll try to give some insight into the patterns, control chart patterns. When I started this lecturing about this control charts for variable, I said exactly control charts can be compared with ECG in medical terms. Okay, electrocardiograph. Okay, it is nothing but the graph, and it will tell us how it is going. That is what even the electrocardiograph they will be knowing. What should be the pulse rate? So, for example, they will get the symbol like this, something like this. So that means something is going on. It goes, then again comes down, then again flat. Instead of this one, if it becomes flat, what is going to happen? They'll conclude ECG is flat. Means what? In some of the pictures, you can see about that. Okay. Similarly, we can read. These are the patterns. They have got the standard patterns. They'll compare, and then with respect to that one, they can analyze it. In a similar way, these control charts can be compared, and the meaningful inference can be drawn, and the suggestions can be given. And these suggestions can be given only with a knowledgeable person who has got the knowledge about the process. He only can draw the conclusions. Okay? And what are those things, possible things? Suppose the process is under control. That means there are going to be the natural variations. Okay? That means it is going to follow normal distribution. That means try to understand when we are drawing the control charts, there are three things. That is what I have seen. One is central line, upper control limit, lower control limit. Whether it is X bar chart or R chart, we have these three. So normal in the sense what? If you take, it doesn't mean that all the points should fall within the center, above the central line, but below the upper control limit. If it behaves like that, something is changed. Even though defective parts are not produced, but it is not a healthy sign. In natural this thing what? 50% of the value should be above and 50% almost below the central line. That is, it is behaving normally. These are due to the chance causes. Okay? Nothing is to be done. You leave the process as it is. Don't disturb. Everything is fine. Okay? Got this one? Now, when we say that the process is out of control, this is what I said, the chance process of variation. That means if you go on connecting like this, these points, it will behave like this. This is perfectly normal. Okay? Then we cannot assign any reason for this. These are because of the natural, this variation, natural causes. Nothing much could be done. But there are unnatural pattern of variations or assignable causes. Under these circumstances, how does it behave? It behaves, one of the things, because if it is assignable cause, what are the various assignable causes and what are their patterns? We will just see. In assignable these things, the important types of assignable cause patterns of variations are extreme variations. Extreme variations in the sense we should have expected like this, but here what happens? Something will fall, one point it has fallen, and then it falls here, then it comes here, then again it behaves like this, and again it goes out of control because of lower these things, again it comes back, again it goes like this. This is extreme variation. Even though one or two, it behaves, because when we plot, it is behaving like this. It is not behaving in a normal way. Extreme. Okay? These are extreme variations. Why these extreme variations will be there? What could be the possible cause? Maybe error in measuring instruments. Okay? Or the calculations. Or tool setting is done wrongly. What is the time? Still I have got time. Okay. Some 4-5 minutes I will just take, so that I want to wind up. These could be the reasons. The next assignable cause variation is indication of the trend. That means it is upward trend or it will go on, it is within the limits, but it will go on increasing in this way or it will go on decreasing in this way. Usually this trend can be observed on R chart. This is for X bar chart. For R chart, because lower limit is, it is going to be 0. Okay? That is what we can observe. This is the downward trend or upward trend. Downward trend in case of this one, because it is 0 in case of R chart. This is preferred. You are taking certain action and it will go on doing like this. But if you look at this, it will go on increasing. We need to assign the reason. There is an assignable reason for this. Another thing is what? Control charts for X bar chart. Again, these three limits. What it will happen? It will come all the values, and then most of the values will be here. That means from here process average has been shifted to this side, or it might be other way around. Okay? That means there is a shifting of process. That has not gone out of control, but it has shifted. Because we expected that they should have crowded around this central value. Now the central value has become this, and soon they might fall about this one. So the actions are required in this case. That is nothing but the shifting of average. It has taken place. Why it has taken place? Maybe because of the tool wear. Okay, that could be the reason for that. Another last one we can think about is erratic variations. So suddenly it will behave erratically. So these are the possible patterns, and you should be able to draw it and explain about it. Thank you. So I'll be concluding the